Hello there, Earth and Space kiddos. This is Mrs. O'Neill. I just wanted to sort of post my own read-through of the notes, kind of the way that we used to do it in class, even though now we're all home alone and very sad about that. I do miss you guys, and I miss having regular class sessions, but hopefully this will help bridge the gap until we can get back to school like normal. Our last unit for the year is going to be about weather. Fortunately, this is actually, I think, easier than what we've been learning so far about astronomy and astronomy and Earth and space and stuff like that. We're just going to focus on weather conditions, weather predictions, and tornadoes, storms, stuff like that. This should be all we do for the rest of the unit, and I will be posting notes and videos twice a week on Tuesdays and Thursdays, and then on Mondays and Wednesdays we'll be doing very short, easy little science at home sort of mini projects that you can do, and then you can record the outcomes of those in the science log that you created on Monday. So that's sort of the plan going forward. Then on Fridays there'll be open note quizzes that'll make up for the test. At this point I'm not really planning on having a whole unit test. This is just so strange and unusual. I don't want to put that kind of pressure on you guys. So this is just where we are and what we're doing. So let's go ahead and get started. So definitions. Weather is the state of the atmosphere in a given location at a given time. This is different from climate in that weather is very short term. This is today and tomorrow and next week. Climate is long term. It's weeks and months and years of information. Weather is always sort of a temporary thing. It can change rapidly. The weather occurs and changes in weather occur due to the energy from our sun being very unevenly distributed. There's more sun hitting the tropical areas compared to the polar areas. That creates uneven heating and large temperature differences, and that can cause changes in pressure. And then we have motion of the air from one place to another, which causes wind. And stuff like that. So there's lots of different factors that are involved. The weather is a very complex system. This includes things like air pressure, temperature, wind, humidity, and precipitation. Today we're just going to talk about all of these very briefly, and then we'll go through each of them individually in more detail as we go through the unit. So our major factors. The first, and probably the one we're most familiar with, is temperature. Temperature is actually a measure of speed. The faster your particles are moving, the higher the temperature. The difference between cold water versus hot water is how fast the water molecules are actually moving. Higher temperatures is faster speed. We do use 3 different temperature scales. Whoops, that just jumped right down, didn't it? I'm not going to be editing these videos very much. I have to make like 10 of them a week, and I don't really have time to make the videos and edit them. So whatever strange little glitches occur, I'm just going to leave in for entertainment. So don't worry about that. In a classroom setting, there's always going to be strange little glitches anyway. But here's our 3 temperature scales: Fahrenheit, Celsius, and Kelvin. We're very familiar with Fahrenheit. This is obviously the one that we use most often here in the States. To set us sort of at a comparison point, in Fahrenheit, the freezing point of water is 32, and the boiling point of water is 212. And so you can have 100-degree Fahrenheit weather, and that's okay. It's not the end of the world. The highest temperature ever recorded here in the United States was in Death Valley, California, at 134 degrees Fahrenheit, which is just ridiculously hot. Here in Kansas, we get maybe 105 in the really bad days. But, if you get up to 200 degrees Fahrenheit, that's like the oven-type weather. You don't go outside. Now, if you were over in Europe and you told someone it was 100 degrees outside, they would flip right out, because 100 degrees Celsius is 212 degrees Fahrenheit. The boiling point of water. With Celsius, we set the freezing point at 0, the boiling point at 100, and then they just split it up in between. This is a shorter range, 0 to 100, compared to 32 to 212, and so each individual degree Celsius is bigger compared to an individual degree Fahrenheit. And then what we consider like normal temperatures, like a average room temperature, which is like 75 degrees Fahrenheit, is like 25 degrees Celsius. If you told someone, we'll ignore that too. If you told someone that, if you told them that it's 100 degrees Celsius outside, they would think you would die. Because, we wouldn't be going outside if it was 212 degrees Fahrenheit. Okay, my laptop did not like that much, but hopefully it didn't just black out. Alright, so moving on. Kelvin is just like Celsius, but it recognized a problem we were having. Down here, we have all these negative numbers. And in math, random negative numbers are pretty bad, because then you get things like negative volume or negative time. And it messes up your calculations. So for Kelvin, we got rid of all the negative zeros by starting at absolute coldest possible temperature. Since temperature is speed, you do have a slowest possible speed, 0, going nowhere. And so you can have the slowest possible temperature when the particles are going nowhere. That's absolute 0. 0 degrees Kelvin, and we just counted up from there. We kept everything else the same though. So it turns out 0 Kelvin is 0 degrees Celsius is 273 Kelvin, and then 100 Celsius is 373 Kelvin. And so the size of a degree Kelvin is the same as the size of degrees Celsius. We just changed our starting location, which is negative 460 degrees Fahrenheit. That is super cold. Much colder than it's gotten anywhere here on Earth, even on the moon. I like this little image here. The moon is only negative 280 degrees Fahrenheit, and we still wouldn't want to be living on the moon. Too cold. Okay, moving on. This is what I was saying. Absolute 0, the coldest possible temperature where particles stop moving. Kelvin has no negative numbers because math. Basically, the negative numbers are bad for math. So that was all number 1. Number 2, the rest of these are faster. We're just talking about wind. Wind is air particles moving from areas of high pressure where the density is high to areas of low pressure where the density is lower. And then the little device that we use to measure it, you probably seen it. It's like a little spinning thing with cups on the ends. It's called an anemometer, which is just fun to say. Anemometer. Then we also talk about humidity, the amount of water vapor in the air. The warmer the temperature, the more water vapor there can be. And this can lead to condensation occurring. The changes from a gas phase into liquid particles, and that's how we get clouds and eventually precipitation, which is like rain. We call the air saturated when it's got the maximum amount of humidity at a particular temperature. And this is going to be important because the amount of water vapor in the air leads to a lot of other phenomenon. Like we already mentioned, cloud formation and rainfall and stuff like that. If it wasn't for the water vapor, we would not have those things. But just giving you a number for humidity is not very useful. And so when we talk about it being, crazy, it's 90% humidity out today. That's our relative humidity, not the absolute. We're just comparing the amount that we've got to the maximum amount possible and then giving that as a percentage. And that can change based on the temperature. Because as the temperature falls, the water vapor in the air stays the same, but the amount of water it can hold would go down. Like the maximum amount would go down, and so your percentage actually goes up. When it hits 100, that's when things start to happen, like dew. As the air cools, the amount of water it can hold goes down, and the relative humidity goes up, and then when it reaches 100%, there's condensation, dew forming, onto colder surfaces like your car, the blades of grass, or whatever. If it's below freezing at this time, instead of liquid water and dew, we get frost. Same phenomenon, same sort of process, just a different phase, a solid instead of a liquid. We call the temperature at which the dew starts to form that evening the dew point, and this varies depending on, how much humidity there is in the air. Mostly, if it's really dry, your dew point might be really low. But the higher the humidity, the higher the dew point will be, and so we can get a lot of dew on these days, like we've had lately, where it's all overcast. But, okay, that's actually the end of the notes for today. We're going to talk about clouds and wind and storm fronts and tornadoes and all sorts of stuff as we go through this unit. We'll be doing these notes and videos twice a week, and then also doing some fun lab activities twice a week, and then rounding it all off on Fridays with a multiple choice quiz. The quizzes are open notes. The whole thing should be really laid back. I think this is a fairly simple unit. I'm kind of hoping it won't be too stressful for everyone as we're adapting to these new situations. Thanks so much for watching the video, and I hope it helped. Have a great day, and I'll see you again soon.